is to teach you how to assign oxidation numbers, and it is part of the assignment in electrochemistry, where you are going to have to learn how to assign oxidation numbers. So the students will be able to determine the oxidation value for atoms, ions, and molecules. And then eventually we're going to be using those in a half reaction method for balancing redox equations. We're going to do it both in acidic and in basic solutions. So this is a video on how to assign oxidation values or numbers. If you remember in the beginning of this class, we were looking at this periodic table, and we divided it here at the Cootie line. And I told you how to determine what the charge was for writing a formula. And for example, if we look at the things in column 1, everybody here in column 1 has a number assigned to it. What number is that? Go ahead and give it a try and answer the questions as we go along, so that you can get the most out of this video. So if you remember, everybody in column 1 had a charge of +1. And everybody in column 2 had a charge of +2. In this section, which is the transition metals, we said they were unpredictable. And that's because if you look, there is a variety of different numbers there. What is that number? Go down here and look at the key for a second. It's assigning oxidation numbers that we're talking about, and you'll notice here it says the oxidation numbers, the common oxidation numbers, which we've been calling charges for writing formulas. So the oxidation numbers are given here for each of the elements, and sometimes there's more than one. And when we were writing formulas with that, we told you that they had to tell you what is the oxidation number for it, and they would do it with a Roman number. And then over here with the nonmetals, we did if you were 1 away from the noble gas, you were a -1. And if you were 2 away from a noble gas, you were -2. If you were 3 away from a noble gas, your charge was a -3. If you were 4 away, you were -4. Keep in mind, it's also 4 away going that way, so that column also has +4 values. And if you remember, the B was on the wrong side of the line, and it's always a +3. But I told you that the time we came back from spring break, I would talk to you more about the multitude of numbers that are over here on these non-metallic elements. Now you'll notice the only one that doesn't have a multitude of numbers is fluorine. She's the only one that just has one number, a -1. So now we're going to be talking about how do we know when bromine is that default -1 that we've just been using, and how it's one of these other numbers, because as you can clearly see, it's not always a number -1. Sometimes it is a different number, and so that's what this video is going to be about. It's how to assign those oxidation numbers for the elements when they don't have the typical standard oxidation number that we've been using thus far. Okay, so the reason we need to know how to do that is if you'll notice on normal standardized tests, they give you a periodic table that looks more like this, and you'll see they don't tell you the oxidation numbers on this form. So that means they expect that you do know how to assign the oxidation value. So let's look and learn how to do that. There's a set of rules, and they are presented in a hierarchy. So what's this word hierarchy mean? It means they're in order of their importance. So rule number 1 is more important than rule number 2. But rule number 2 is more important than rule number 3. So if I'm looking at these 3 rules at the same time, which sometimes you will be, rule number 1 is first, followed by rule number 2, and then rule number 3. There's actually quite a few more rules than what we're going to go over, but we're going to give you the basics by giving you 5 rules to know. You must know these 5 rules for the test in order to finish the test in a timely manner. So make sure you do memorize these rules. All right. So rule number 1 is that if you are looking at a whole compound, for example, H2O. I'm looking at the compound H2O. And it says in this rule, the sum of the oxidation numbers in a neutral compound is 0. That means the oxidation numbers on your H's and the oxidation number on your O's all add up to having a charge of 0. Now, we don't write a 0 there. It's just blank when it doesn't have one. And we already know that compounds are neutral. So compounds are neutral, and neutral means a charge of 0. So the oxidation total for an H2O is equal to 0. All right. Also part of rule number 1 is that the oxidation of the sum of the oxidation numbers in a polyatomic ion is equal to its charge. So let's say we have SO4, that's sulfate. You know its charge is -2. So they're saying all of your S's and your 4 O's, if you add up their oxidation numbers, they're going to come out to 0. So the first rule is all about groups. So compounds, which are groups, and polyatomics, which are groups. Rule number 2 is all about individuals. It says the oxidation number of an uncombined atom is 0. So, I just have myself an atom of sodium. If I have sodium all by itself, its oxidation number is 0. So any element on the periodic table, when not in combination with anything else, is going to be 0. Remember, we still do have some things that don't actually travel alone. So the oxidation number for hydrogen, which is H2, is also 0. So when they're by themselves, they're 0. Also, the oxidation number for a monoatomic ion, that means an element that is an ion, but it's all by itself. Like, say I told you you had an ion of sodium. That would be an Na+1. And the charge on that would be what it says, a +1. So the ions by themselves are their charge. Whatever their charge is what they say they are. So that's easy. This kind of says it because there's no number on it. So they are what they say they are. They're by themselves. So if we look at our periodic table of the elements, you will see that there are some groupings where we already only have one number on it. So those will eventually be part of our rules. But more often than not, there are oxidation numbers that are varied. So we're trying to figure out what are the different varied oxidation numbers for a particular compound. All right. Rule number 3, and I call this rule the scaly 3. That's because these 3 elements, S, C, A, L, and Y, which are on the periodic table, S, C, A, L, and Y, only have their one charge. Sc is a +3, Al is a +3, and Y is a +3, and they're part of the scaly 3. They're actually number 3 on the scaly 3. So just to let you know, I call this the scaly 3, and I say there are 3 parts to it. Okay, the first part to it is that the oxidation number for fluorine is always -1. And if you look at our periodic table, she's the only girl that just has one oxidation number. So fluorine is always -1. The second part of it I've kind of grouped together because in my mind I would like rule number 3 to just have 3 parts. So I've combined part B and C together and just said to myself, columns 1 and 2, the numbers are what we said they were before. So we haven't changed that. In column 1, the element's oxidation number is a +1. And in column 2, the element's oxidation number is a +2. So I kind of count that together as just one thing, that columns 1 and 2, their oxidation numbers are, in fact, 1 and 2 in that order. And then the third part is that thing that I talked about in the beginning one, that is the scaly 3, S, C, A, L, and Y. Each of those have an oxidation number of 3. All right, so those are set elements. So the first rule was all about groups. The second rule was about atoms and ions by themselves. And the third rule is talking about particular elements on the periodic table. Fluorine being -1, every element in column 1 and 2 being what they are. Column 1 is 1 and 2 is 2. And then this list of SC, AL, and Y having an oxidation number of +3. Rule number 4 is about the element hydrogen. And hydrogen's in a lot of compounds. So the oxidation number of hydrogen is a +1. And that's only if it doesn't interfere, and same with rule number 3, if it doesn't interfere with a previous rule. So sometimes hydrogen will not have an oxidation of +1, and that is if it's in combination with one of the elements that were in rule number 3. It may very well be a -1, okay? So you have to look to see the rules in order. But when no other rule is in play, then the oxidation number of hydrogen is a +1. Now don't get confused. Remember that rule number 1, when it was by itself, well actually that's rule number 2, when it's by itself, it's 0. So I'm not trying to contradict that hydrogen is always a +1. When it's by itself, that's rule number 2. And rule number 2 is higher than rule number 4. And so we would then say it's 0. All right, rule number 5 is about the element oxygen. And the oxidation number of oxygen is a -2. Once again, unless it's by itself, and then that's rule number 2. Rule number 2 says if it was by itself, it'd be 0. Rule number 5 is when it's in combination with something else, it's a -2. Don't forget, there's also exceptions. It's possible it's in conjunction with hydrogen, and hydrogen's rule is rule number 4. So if it's in conjunction with hydrogen, then hydrogen's rule wins. And rule number 5 is after that. So you would use hydrogen's rule if the two of them were together. Let's do some practice problems so you can understand what I'm saying about the rules. So just as a recap, rule number 1 is about everybody together. Rule number 2 is about the elements and ions separate. Rule number 3 has 3 parts. It's the scaly 3. Part 1 of that is fluorine is a -1. Part 2 of that is column 1 and column 2 are 1 and 2, respectfully. And part 3 of that is that the elements SC, AL, and Y are a +3. Rule number 4 is hydrogen is a +1, and rule number 5 is oxygen is a -2. And all of these rules are in a hierarchy, which means they're in order of importance. So we've got two elements here, Mn and O. And I do what I call a mystery box. Rule number 1 is about ions, polyatomic ions. I've got a polyatomic ion, and if you look at rule number 1, it says the sum of the oxidation numbers of the elements in a polyatomic ion add up to the charge on that ion. So they're telling me the elements Mn and 4 O's are going to add up to -1. That's first rule number 1, and you set that up first. All right, then you look at the elements you have and ask, do you have a rule for that? So do you have a rule for Mn? No, it was not one of the elements we have a rule for. Do we have a rule for O? The answer is yes. Rule number 5 says that O's are worth a -2. You'll notice that you have 4 O's. So that's 4 times the -2. That means in my box here, the total of all of my oxygens is a -8. Now I can figure out what Mn is, because Mn, whatever goes in this box, plus a -8 equals a -1. So what number has to be in this box for that to work out? Mn, in this case, is a +7. So if it asks, what's the oxidation number of Mn in this compound? Well, this is not a compound, this is an ion. The answer would be +7. And if it asked, what was the oxidation number for oxygen in this polyatomic ion? The answer to that is -2. Please notice that when they ask you about one element, they really do only mean one of the elements, and so each one of them was a -2. All right, let's try it again. I've got SO3 -2. That is a sulfite ion. How many elements do we have? Well, I have one capital S and 3 capital O's. So I have 2 different elements. I have S's and I have O's. I have 3 of them. And according to rule number 1, these 2 elements, S's and O's, are going to add up to a total of -2. Because the rule says the sum of the elements in a polyatomic ion equal to its charge. All right. Do I have a rule for S? The answer is no. I do not have a rule for S. So I call that my mystery box. Do you have a rule for O? The answer is yes. Its rule number 5 is a -2. And according to the formula, I have 3 of them. So in this box, the overall charge is a -6. So then you ask yourself, what number plus a -6 equals a -2? And of course, that number is a +4. So the oxidation number on the sulfur in this sulfite ion is a +4. And the oxidation number of the oxygen in this sulfite ion is a -2. We're only asking about one of them when they ask about what is the oxidation number of the oxygen. So I don't use all 3 to answer that part of the question. All right, I hope you're feeling good about this. It's pretty easy. Let's try another one. How many boxes am I going to need to set up for my mystery box equation? And if you'll look, I've got 3 capital letters. The lowercase letters, you remember, means that that's a 2-letter symbol. So I've got 3 different elements here. And sometimes this can get a little confusing because you may not have rules for everything, and you might have to rely on your polyatomic ion memorization to answer these questions. But let's give this one a try. So according to rule number 1, if you have a compound, which this sodium perchlorate is a compound, because there's no charge here. See, there's nothing here. Okay, so if I have a compound, it says that the sum of the oxidation numbers equals 0. When you have a compound, the sum of the oxidation numbers equals 0. So now I've got to fill in my mystery boxes here. Do I have a rule for sodium? Now, because we didn't name them outright, you might need to every once in a while check back to your periodic table. If you remember, on your periodic table, we do have rules for columns 1 and column 2, right? We have rules that everybody in column 1 is a +1, and everyone in column 2 is a +2. And if you know, sodium's in column 1. So we do have a rule for sodium. The rule for sodium is it's +1. All right. Do we have a rule for chlorine? All right. If you think back to your periodic table, chlorine is on that side of the zigzag line. And the only person that has a rule in the girls section is fluorine. So that's a nonmetal. Chlorine is a nonmetal, and the only one that has a rule for itself, well, oxygen does have a rule, number 5, but it has multiple things, so sometimes it's not. But the only one that's definite is fluorine. So chlorine is not one of those. So I do not have a rule for chlorine. Do I have a rule for oxygen? I do have a rule for oxygen. Rule number 5 says that every oxygen is a -2. And in this problem, I have 4 of them. So this box fills with a -8. So now I can solve my mystery box problem. What number does the chlorine in this case have to be if +1 plus whatever this mystery number is -8 equals 0? It means that this chlorine had to be a +7. And that's very different than what we used to say it was when we were having our formula writing. We always had chlorine be a -1 because it was 1 away. But we told you we would readdress this after spring break, that we would start talking about those numbers. So that's what we're doing here. So if it asks, what's the oxidation number of sodium in this compound? The answer is +1. What's the oxidation of chlorine in this compound? The answer is +7. The oxidation of oxygen in this compound is a -2. Once again, we answer those questions individually. We don't put all the charge for all of the oxygens. So, how many boxes am I going to need for this problem? Hopefully you said 2. I need 1 for the phosphorus and 1 for the oxygen. And according to rule number 1, what do these 2 boxes add up to be? -3. Do I have a rule for phosphorus? The answer is no. So that's going to end up being my mystery box. Do I have a rule for oxygen? And the answer, of course, is yes. Rule number 5 says that oxygen is a -2. And in this problem, I have 4 of them. So this box here is going to populate with a -8. So what does the phosphorus have to be in this equation? It had to have been a +5. So the oxidation number of phosphorus in a phosphate ion is +5. The oxidation number of the oxygen in a phosphate ion is a -2. Please notice that we didn't say -8. We're only being asked about one of each element whenever they ask you, what is the oxidation number? All right, how many elements do we have here? We have 3 elements. So those 3 elements are going to add up to what number? According to rule number 1, this is a compound because there's no charge there. They're going to add up to 0. All right? What is the rule for hydrogen? Rule number 4 says hydrogen is a +1. What is the rule for nitrogen? I don't have a rule for nitrogen. What is the rule for oxygen? According to rule number 5, oxygen is a -2, and I've got 2 of them here. So that means this box is going to populate with a -4. What does the nitrogen have to be? If 1 plus this mystery number -4 equals 0, nitrogen in this case has to be a +3. So the oxidation number for the hydrogen in this problem is equal to a +1. The oxidation number for nitrogen in this problem is a +3. And the oxidation number for oxygen in this problem is a -2. So now you're prepared to go and work out your oxidation number equations that are found in your Google form.